Alright, let's continue. Okay. While am I again in chapter 11, we already done this symbol syntax. Okay. Alright. Okay. We already the final file copy. The environment. Okay. Wait, let me check. Alpha put this one. Okay. Okay. Interesting. So if we have something like this, so the for loop not using what is it called? The curly bracket. I mean, this is I am not really sure. Linux kernel coding style. Placing brackets and space. Alright, thinking people now. KNR is alright. KNR alright. Functions are special anyway. In C. On the line of its own. Except in the case relational KNR. Do not unnecessarily use bracket where a single segment will do. Yeah, what about the for loop? for loop with the if. Is this gonna make the code harder to read? Maybe. Well, let's try this out. Okay. But yeah, if there is if statement, there's a chance that we might add another statement like this, for example. Okay. Yeah, let's just put the curly bracket if you're having the if statement, I guess. I mean, I think this will be a lot harder to read. Okay. Variable evaluation now depends on some environment. You should pass this in as an argument and use it to get a value if we encounter a symbol type. In as an argument and use it to get a value if we encounter a symbol type. Because our environment returns a copy of the value, we need to remember to delete the input symbol alpha. Okay. Environment returns a copy of the value, we need to remember to delete the symbol. Okay. We get from the environment. Let me check. Oh, we return the copy. I use memory allocation. Okay. Okay. Let's yeah, we need to change that. Start. Let me change in here first. Wait, on second thought. Yeah, let's make this consistent, I guess. If a single statement will do. This is not single statement, so yeah. Never mind. Okay. So if the type is symbol, right? Which mean where is it? Oh no, not this one, but this one. So that is before the symbolic expression. Okay. If value type equal because we already get the new memory allocation here. That means we need to free the value. Okay. Tag alpha. What am I gonna name that? Maybe var the variable. Okay, this. Yeah, we remove this and then return far. Okay. This is, we also need to adjust a symbolic expression too. Okay. And V return value. Okay. Okay, I guess this one, right? Alpha. This one. And then this one. I'm still not sure why we need a spirit for loop. I mean, the looping looks like the same, right? So why can't we just put this in here in this looping? I mean, well, that's what I did, I guess. And for now it's looking fine. So yeah, I'm still not sure. Then this one, if the count is 0, return the value immediately. Count is 1 using alpha tag. Right. Wait. Okay. Almost forgot to add env in here. Alpha tag. envelope pop. Pop, okay. Oh, if not a function, first element is not a function. Interesting. So we are not checking the type to be the symbol anymore, but a function. Okay. First value and then first element a function. If so, call function to get result. Okay. Get function. Oh. So we are not using built-in anymore. Returning the result. Note that our evaluation relies on the new function type. We need to make sure we can register all of our built-in function with the environment before we start the interactive prompt. Relies on the new function type. We need to make sure we can register all of our built-in function with the environment before we start the interactive prompt. At the moment, our built-in function are not correct type. We need to change their type signature such that they take in some environment, and when appropriate change to pass this environment into other calls that require it. The type signature of the built-in function as their first argument now. In other calls that require it. What other calls that require it? That required doing this. I mean, do we need to do it like this? What's wrong with this implementation? Wait. Okay, let me take this one. Where is the built-in? Hold on a minute. Where is the built-in? The built-in function. There's built-in head, built-in tail. Built-in add, sub. Is this the one? Built-in def. I mean, if I remember correctly, in the previous chapter, built-in list. I don't remember implementing that. But in never see, we are using built-in as the function name. Yeah, this is kind of. Did I miss this? Oh, alright. I don't remember that. My bad. Okay, so maybe in chapter 11 we change is this a new function or replacement for the previous built-in function name? That is quite confusing. Or maybe this one. I mean, let me check again. What is the built-in OP or operator to this one, right? Do we really need the environment here? Okay. For now. Where are we gonna using this? Gonna pop. Okay. No. We didn't really use the environment here. I guess. Where is it? Okay. Maybe we change the built-in function to be like this. Or this one maybe. Oh. That's why we create a spirit function. Well, okay then. And built in if we are passing in wait. Okay, so we initialize the environment here, we then passing that to here. Let me check. What is the type? Interesting. Where is the type? We didn't really provide any type when we initialize the new environment. So and within are we just gonna what is it called? Put all of this function in the environment. Is that it? It's our name, right? And so this means that we initialize the symbol with this name, and then we initialize a function with this function name. So this is okay. Let me try. So let's say that this environment. So we create new environment, right? And then we initialize. Let's take this for example. Initialize the list. The list as function name in env. Yeah, this one, right? And then we initialize function one. Function in function. Put in function with the list name in env. Maybe something like this. And then of course we free the allocation in here. Okay. Having plus must put in add. So So yeah, I'm not sure if we will use this function again. So maybe add the new function. In the environment, okay. An operator. And then after add, okay, how many arithmetic operator do we have? Add, multiply, subtraction, divide, right? Yeah, this make me curious. Can we like, what is it called? Rather than making this function one by one, can we like putting this in the, what is it, in an array and then doing the looping, you know? But yeah, Like this is the Lisp function, you could say, and then this one arithmetic function. Let's try that out. And put in. Put in. Where should I put this? Yeah, this make me wonder. Should I put the environment? The initialize environment at the top. I mean, from this statement, it looks like we always initialize the environment. You know what? Let's put the environment first and then the value. So this one go to the top before eval, before value evaluation. But yeah, alpha tail. Alpha put. Is it really alpha put? The name of the function. Okay, env put, right? We put get on second thought. Yeah, I think let's put the environment at the bottom. I think. Yeah, because most likely we're not gonna change the function environment that much. Maybe. Okay. Guess 10 more minutes. before I need to go, yeah, first of all, we need to add this. Void env put in, okay, struct env struct alpha for the value, the lips value. Oh, okay, so we are not okay. We put the name as the parameter. Okay, then I'll put in for the function. And now we put that in get. Void env put in, right? And then struct char name from struct info. Do we need to do this? I mean, again, if we take a look at alpha put, lenv put, right? We are only using key for the symbolic name, right? See, only for the symbolic name, we are checking whether the symbol name already exists in our environment or not. If it is exists, then we delete the value, the previous value or the current value, and replace that with the new value. And from this code, we are only using this one. And that is why in my implementation, I directly use this, what is it called? Pointer to char. Because we are only using the string allocated to it. So yeah, I'm not sure if we need to do this. Maybe we can just pass this directly to env put, But yeah, for this one, I think we still need to do that. And then alpha, not alpha, env put, and then checking env, I guess, name fun. Alright. This make me curious. Is there any possible error? Wait a minute. When we are trying to put why? Have a copy. This one. Yeah, I mean, if there is an allocation error, we will exit the program. Maybe not now. Well, let